The topic is chemical equilibrium. Let us do some objective questions on chemical equilibrium. Let's start with question number 1. The question is, equilibrium constant for the reaction H2 plus I2 gives 2HI. If 10 moles of HI was produced by the reaction between 15 moles of hydrogen and 5.2 moles of iodine, vapor is. First option 1.282, second option 0.78, third option 50, and fourth option is 7.8. Let us solve this question. H2 plus I2 gives 2HI. This is the reaction. We are starting with 15 moles of H2 and 5.2 moles of iodine. This is the initial amount. At equilibrium, we are getting 10 moles of HI. If this is 10, see, as per the equation, 1 mole of H2 is giving 2 moles of HI. So, 10 moles of HI would be produced from 5 moles of H2. So, 5 moles of out of 15 moles is consumed. So, how much H2 will be left out? It will be 10. And how much of this will be consumed? 5 moles will be consumed because you are getting 10 moles of this. 0.2 will be left out. Now, write Kc expression. Kc equals to concentration of HI raised to the power 2 by concentration of H2 into concentration of I2. If you put the values, you get 10 into 10 by 10 into 0.2. That comes to 50. So, the correct answer is third option 50. Question number 2. For the reaction H2 plus I2 gives 2HI, the equilibrium concentration of H2, I2 and HI respectively are 8, 4 and 28 moles per liter respectively. The equilibrium constant is. Let us write the equation. H2 plus I2 gives 2HI. You are given equilibrium concentrations of H2, I2 and HI. H2 is 8, I2 is 4 and HI is given as 28. And you are asked to find out the equilibrium constant. So, Kc equals to 28 into 28 divided by 8 into 4. This goes 7 times. So, it comes to 49 by 2, which is 24.5. So, the correct answer is first option 24.5. Question number 3. The equilibrium constant of the reaction A2 plus B2 gives 2AB is K. The equilibrium constant of AB gives rise to half A2 plus half B2 is. First option root over K, second option 1 by root over K, third option 1 by K, fourth option is K. See, the equilibrium constant value depends upon the mode of writing equation. If you revert the equation, then the equilibrium constant will be the reciprocal of the original one, and if you divide an equation by 2, then the equilibrium constant will be the square root of the original one. So, here we have done 2 operations. We have not only reverted the equation, we have also divided it by 2. So, the correct answer is 1 by root over K. We have done 2 operations, reverted the reaction, that is why K will go in the reciprocal, and then we have divided the entire equation with 2. So, we need to take the square root of that. So, the correct answer is second option 1 by root over K. Question number 4. The equilibrium constant of CaCO3 solid, this is a solid, gives rise to CaO, which is also a solid, plus CO2, which is a gas. So, what is the equilibrium constant for this? So, Kp equals to PCO2. These two are neglected because they are solids. So, the correct answer is third option PCO2. Question number 5. 8 moles of Ab3 present in 1 liter vessel dissociates as 2 Ab3 gives rise to A2 plus 3 B2. At equilibrium 2 moles of A2 are found to be present. The equilibrium constant is. Let us write the equation. 2 Ab3 gives rise to A2 plus 3B2. 8 moles are present initially. At equilibrium, you have 2 moles of A2. This is 2 moles. As per the equation, 2 moles is giving 1 mole. So, 2 moles of A2 will be formed from 4 moles. So, how much will be left out? It will be 8 minus 4. For every 1 mole of A2 formed, you are getting 3 moles of B2. So, for 2 moles, this will be 6 moles. Now, Kc equals to concentration of B2 raised to the power 3 into concentration of A2 by concentration of AB3 square. So, you need to substitute these values. So, 6 cube into 2 by 4 square. This comes to 6 into 6 into 6 into 2 by 4 into 4. This goes 2 times, this goes 3 times, so that comes to 27. So, the correct answer is fourth option, 27 mole square per liter square. Question number 6. The volume V of a closed vessel in which the equilibrium 2SO2 plus air gives 2SO3 established is reduced to V by 3. Then, first option, the rate, you are just decreasing the volume from V, you are making it V by 3. What happens to equilibrium constant? Let us look at the options. The rate of forward reaction is not affected, the rate of backward reaction is not affected, the value of Kp is not affected, the value of Kp changes to 1 by 3 Kp. Fourth option is an incorrect statement. Actually, the value of Kp does not change. So, the correct answer is the value of Kp is not affected. Kp and Kc, these two values are dependent only on temperature. They do not depend on concentration or any other factor. They depend only on temperature. Question number 7. The equilibrium pressure of the reaction NH4HS gives rise to NH3 plus H2S is 10 atmospheres. The value of Kp is, first option 25, second option 25 atmospheres square, third option 10 atmospheres, fourth option is 10 atmospheres square. Let us try to find out. This is a solid. You get two gaseous substances, NH3 gas plus H2S gas. The pressure is P total equals to P NH3 plus P H2S. This is 10 atmosphere. So, and these two must be equal. See, every 1 mole of this will dissociate into 1 mole of ammonia and 1 mole of H2S. So, P NH3 is equal to P H2S, which is equal to 5 atmospheres. Why? Because the sum of these two is equal to 10 atmospheres. So, definitely each one has to be 5 atmospheres. Kp equals to PH2S into PNH3, that comes to 25 atmosphere square. So, answer is option B. Question number 8. For the equilibrium 2SO2 plus air gives 2SO3, delta H is equal to minus 189 kilojoules. The favorable condition for high yield of SO3 are, first option low pressure, low temperature, second option low pressure, high temperature, third option is high pressure, low temperature, and fourth option is high pressure, high temperature. See, you need to apply Le-Chatelier principle. Now, in this process, if you see 2SO2 plus O2 gives rise to 2SO3, 3 moles of reactants is changing into 2 moles of product. So, there is a decrease in number of moles. So, high pressure will favor formation of SO3. And since the reaction is exothermic, it is favored at low temperature. So, you need high pressure and low temperature. So, the correct answer is third option, high pressure and low temperature. Question number 9. For the reaction SO2 plus half O2 gives SO3, the value of Kc is at 727 degrees Celsius is 200. The value of Kp is, the value of Kc is 200. The value of Kp is asked. See, look at this formula, look at this equation. SO2 plus half O2 gives rise to SO3, right. For this, delta n is minus 0.5. Total moles of gaseous products minus total moles of gaseous reactants, that comes to minus 0.5. And we have this relationship Kp equals to Kc into RT power delta n. This is the expression. So, Kc is given as 200. So, Kp equals to 200 into 0.0821 into 1000. This is temperature, because 727 you need to add 273, that becomes 1000, and power minus 0.5. If you simplify this, you get the Kp value as 21.9 approximately. Question number 10. Kp for the reaction N2 plus 3H2 gives 2NH3 at 400 degrees Celsius is 1.64 into 10 raised to minus 4. The value of Kc is. The reaction is N2 plus 3H2 gives rise to 2NH3. For this reaction, delta n is minus 2. So, Kp is given as 1.64 into 10 raised to minus 4. And what is asked is Kc. Temperature is given as 400 degrees Celsius. What you need to do is use this formula, Kp equals to Kc into RT power delta n, or Kc equals to Kp by RT power delta n. Substitute the values. On substituting Kp 1.64 into 10 raised to minus 4, R as 0.0821, and then T is taken as 673 Kelvin, then you get the value 0.513. So, the answer is Kc equals to 0.513. You get it on substitution of these values. Delta n has to be taken as minus 2 here. Answer is third option. Question number 11. For the equilibrium C solid plus CO gas gives 2CO gas. This is the equation. C solid, CO2 gas gives rise to 2CO gas. Kp is 160 atmospheres. At 1000 degrees Celsius. Partial pressure of CO in equilibrium with CO2 at a partial pressure of 0.1 atmospheres is. PCO2 is 0.1 atmospheres. PCO has to be calculated. This is the question. Kp equals to P square CO by P CO2. This is 160 P square CO by 0.1. So, P square CO is equal to 16. So, PCO equals to 4 atmospheres. So, the correct answer is second option, 4 atmospheres. Question number 12. The amount of PCl5 to be taken in a 1 liter vessel in order to obtain a concentration of 0.1 m of Cl2 at equilibrium when Kc for PCl5 gives PCl3 plus Cl2 is 0.0414 m. The equation is PCl5 gives rise to PCl3 plus Cl2. The amount of PCl5 to be taken in a 1 liter vessel in order to obtain a concentration of 0.1 m of chlorine at equilibrium when Kc is 0.0414, right. Now, you want 0.1 m chlorine. If 0.1 m chlorine is to be formed, then the amount of PCl3 formed should also be 0.1, because these are formed in 1:1 ratio. And then imagine the initial amount of PCl5 you have taken is x, then at equilibrium it will be x minus 0.1, because for every 0.1 m of chlorine you need to consume 0.1 m of PCl5. So, this is how the equation is. Now, Kc value is given as 0.0414. So, 0.0414 is equal to 0.1 into 0.1 by some y is equal to x minus 0.1. So, y equals to 0.1 into 0.1 by 0.0414. So, this comes to 0.24. So, x equals to 0.34, this value you get. Y is equal to 0.24, y is nothing but this one of this. So, x equals to 0.34. The answer is first option. Question number 13. The Kp value for the equilibrium reaction CO plus C gives rise to 2CO at a certain temperature T is 0.3. The Kc value for the equilibrium reaction is CO2 plus C gives rise to 2CO. This is the reaction where C is a solid, these two are gases, right. Kp value is 3. The delta N value for this is 1. Kp value is 3 and you are asked to find out Kc. We know that Kp equals to Kc into RT power delta N, that is 1. So, Kc equals to Kp by RT. So, the correct answer is third option, Kc is equal to Kp by RT. Question number 14. The pH of 0.0008 molar magnesium hydroxide is. Let us consider magnesium hydroxide as a strong base, because the data given is insufficient. We need to take it as a strong base only. This gives Mg 2 plus plus 2 OH minus. So, the concentration of OH minus we can take it as 2 into 0.0008. So, OH minus concentration is 16 into 10 raised to minus 4. Now, POH equals to minus log 16 into 10 raised to minus 4. Log 16 is 1.2, this is 4. 4 minus 1.2, it comes to 2.8. So, pH is equal to 14 minus 2.8, it comes to 11.2. So, the correct answer is second option, 11.2. Question number 15. pH of 10 raised to minus 8 molar HCl is. HCl dissociates to give H plus plus Cl minus. This is 10 raised to minus 8. We need to consider the dissociation of water also. H plus plus OH minus, this you take as 10 raised to minus 7. So, total H plus concentration will be 10 raised to minus 7 plus 10 raised to minus 8. You need to add up these two and then take minus log. Remember, solution of acid will always have pH less than 7. So, the nearest value you get is 6.96. Answer is fourth option. Question number 16. If acetic acid is ionized to the extent of 2.3% in 0.02 molar aqueous solution, the pH of the solution is. Alpha equals to 2.3 by 100. This is degree of dissociation, and then molarity is 0.02. You are asked to find out pH of the solution. See, concentration of H plus is equal to C alpha square. So, this comes to 0.02 into 0.023 into 0.023. That gives concentration of H plus, and pH equals to minus log of concentration of H plus. This is how it can be done, and the answer you get is 4.34. On simplification you get this answer. Answer is first option, 4.34. Question number 17. A solution of benzoic acid is titrated with sodium hydroxide. The pH of the solution when half of the acid was neutralized is 4.2. The dissociation constant of benzoic acid is. See, half of the solution is neutralized. See, when you do the titration, benzoic acid plus sodium hydroxide, you get sodium benzoate plus water. At halfway, the concentration of benzoic acid will be equal to concentration of benzoate. At midways, during titration, these two will be equal because half of the benzoic acid has been changed to sodium benzoate. So, these two will be equal. Now, you get an acidic buffer. So, pH equals to pK plus log sodium benzoate concentration by benzoic acid concentration. When these two are cancelled out, you get log 1 equals to 0, then pH will be equal to pK. Now, it is given as 4.2. This is equal to 4.2. So, K equals to 10 power minus 4.2. So, it comes to 10 power minus 0.2 into 10 raised to minus 4. Then this is equal to 10 raised to 0.8 into 10 raised to minus 5. You need to take antilog of 0.8, it comes to 6.3. So, the answer is 6.3 into 10 raised to minus 5. Answer is second option. Question number 18. The concentrations of acetic acid and sodium acetate in a buffer solution of total molarity 0.39. Total molarity means this is the molarity of acid plus molarity of salt is 0.39 m. Having a pH of 4.4 if the K of acetic acid is 1.83 into 10 raised to minus 5. Let us try to solve this question. The formula is like this: pH equals to pK plus log concentration of salt by concentration of acid. This is the formula. Now, K value is given. So, pK is approximately 4.7. It is minus log of K gives pK, minus log of 1.83 into 10 raised to minus 5 comes to approximately 4.7, and pH is 4.4. So, you can say log of salt by acid is equal to pH minus pK, that comes to minus 0.3. So, salt by acid is equal to antilog of minus 0.3, that comes to 1 by 2, and salt plus acid is equal to 0.39 as given in the question. So, solving these two, you get the concentration of acid and concentration of salt. The correct answer given is first option, 0.26 and 0.13. So, if you take the ratio 0.13 by 0.26, that comes to 1 by 2, and if you add 0.26 and 0.13, that gives 0.39. So, that is how answer is first option. Question number 19. The pH of the solution having 0.2 molar ammonium chloride and 0.1 molar ammonium hydroxide if pKb of ammonia solution is 4.75. It is a basic buffer. So, for basic buffer, POH equals to pKb plus log salt concentration by concentration of base. pKb is 4.75. So, this is 4.75, and having 0.2 salt is 0.2 and base is 0.1. So, log 0.2 by 0.1, this is equal to POH. So, it will give this is log 2 is 0.3. So, 4.75 plus 0.3 is equal to 5.05. So, pH equals to 14 minus 5.05, that comes to 8.95. Correct answer is fourth option, 8.95. Question number 20. The pH at the equivalence point when a solution of 0.1 m acetic acid is titrated with a solution of 0.1 m sodium hydroxide is pK of acetic acid is 4.7. Let us see. This is the reaction which is taking place. Acetic acid reacts with sodium hydroxide and you get sodium acetate plus water. When these are mixed, because these two are in having same molarity, the solution of sodium acetate will have the concentration of acetate half of what you have for acetic acid and sodium hydroxide. So, the concentration of this will be 0.05 because this is 0.1 m, this is 0.1 m. So these are consumed in equal volumes, so the volume becomes double, so concentration becomes half, it becomes 0.05. We have a formula, salt hydrolysis formula, POH equals to half into pKW minus pKa minus log C. This is the formula used to calculate the pH. So it comes to half into 14 minus 4.7. This is what is given, pK of acetic acid, minus log 5 into 10 raised to minus 2. So you get 14 minus 4.7. This becomes 1.3, and 14 minus 4.7 comes to 9.3, and it becomes 10.6. So 10.6 by 2, 5.3. So pH will be 14 minus 5.3, 5.3. This comes to 8.7. So the correct answer is 8.71, first option. Question number 21. If the solubility of silver sulfate is 1.5 into 10 raised to minus 2 moles per liter, the solubility product in moles cube per liter cube is silver sulfate. Ag2SO4 gives rise to 2Ag plus SO4 2 minus. This is 2S, this is S, Ksp equals to 4S cube. And now S is given as 1.5 into 10 raised to minus 4. So if you put the value S equals to 1.5 into 10 raised to minus 2, if you put this value, you can get Ksp value, and the value comes to 1.35 into 10 raised to minus 5. So Ksp equals to 4 into 1.5 into 10 raised to minus 2 whole cube. So using this, you can find out Ksp. It comes to second option, 1.35 into 10 raised to minus 5. Question number 22. If the concentration of Ag plus N in saturated solution of silver oxalate is 2.3 into 10 raised to minus 4 moles per liter, the solubility product of silver oxalate is. Look at the formula, silver oxalate Ag2C2O4. It dissociates to give 2Ag plus C2O4 2 minus. The concentration of Ag plus is 2.3 into 10 raised to minus 4. The concentration of oxalate will be half of this, so it will be 2.3 into 10 raised to minus 4 divided by 2. Now you are asked to find out solubility product. So putting this and this value in the expression, Ksp is equal to C square Ag plus into C2O4 2 minus. Concentration of Ag plus square and concentration of oxalate, the product of these two will give Ksp, and the answer comes to 6 into 10 raised to minus 12, fourth option. Question number 23. When 100 ml of 0.01 m sodium sulfate and 100 ml of 0.01 m lead nitrate are mixed, then Ksp of PbSO4 is given as 1.3 into 10 raised to minus 8. Now you need to find out whether precipitation takes place or not. See, the substance which can get precipitated, PbNO3 taken twice, this is a soluble substance, and you are adding sodium sulfate, this is another soluble substance, and you can expect it to give PbSO4 plus NaNO3. Remember, this is also a soluble substance, this is soluble substance, this is soluble, this is insoluble substance. If any precipitation forms in this reaction, it has to be a precipitate of PbSO4. We have to find out whether precipitation of PbSO4 takes place or not. See, there's only the likely change which can take place, because there is no chance of precipitation of sodium nitrate, there is no chance of precipitation of sodium sulfate, there is no chance of precipitation of PbNO3 taken twice, because these three are soluble salts, and so the answer is precipitation of PbSO4 takes place. The third option is the answer. What you need to do is verify this. This is the condition which is to be satisfied. Qsp should exceed Ksp. So whatever concentrations are given, from that you can find out Qsp and compare it with Ksp. Let's do it. Concentration of sulfate after mixing, because before mixing it is 0.01, after mixing it will become 0.005, because volume becomes double. You are mixing 100 ml each of two solutions, right? Now concentration of PB, before mixing the concentration of PB in the lead nitrate it's 0.01, after mixing this will become 0.005. So QSP equals to, you need to take product of these two, 0.005 into 0.005. This is 5 into 10 raised to minus 3, this is also 5 into 10 raised to minus 3. If you multiply these two, you get 25 into 10 raised to minus 6, or 2.5 into 10 raised to minus 5. This is QSP. Now KSP, which is given, is KSP is 1.3 into 10 raised to minus 8. You can realize QSP value is greater than KSP value, so precipitation takes place. Answer is third option. Question number 24. The pH of solution obtained by mixing 800 ml of 0.05 normal sodium hydroxide and 200 ml of 0.1 normal HCl. See, we are mixing acid and base, and we need to find out the normality of mixture. Once you find out normality of mixture, from that you can find out the pH of resulting solution. See, we are mixing HCl. HCl is how much? 200 ml, 0.1 normal. Sodium hydroxide we have taken it as 800 ml, 0.05 normal. Now normality of mixture, this 200 into 0.1 comes to 20 milliequivalents, and this is 40 milliequivalents. So VBNB minus VANA divided by VA plus VB. This will give normality of mixture. It comes to 800 into 0.05, that comes to 80 into 0.5, or 40 minus 20 by 1000. That comes to 20 by 1000. Normality of mixture is 20 by 1000. It comes to 2 by 100, 2 into 10 raised to minus 2. This is the normality of mixture. The solution is basic. So the POH will be, POH is equal to minus log 2 into 10 power minus 2. This comes to 2 minus 0.3, 1.7. So pH equals to 12.3. So the correct answer is third option, 12.3.